Hi, I'm back with my second learning. This is the second video of the playlist. You can see the overview here. I will listen and watch the whole video and make notes in my Notion and also in my hand notes in my notebook and also tell you what I learned today. You can click on that GitHub link given below or the summary of the video where you can see their GitHub link for second class. Okay, read or translate the summary in your own language using AI. Okay, first of all, let me finish the video. So, I have finished the video. This is my Notion note. You can see I've written something in English, also in Bangla, in my language also. So, first of all, the first agenda, why do you need programming language? And what is a programming language? A programming language is a structured set of instructions and rules used by humans to communicate commands and solve problems through a computer. Through programming languages, we can explain real-life problems to the computer. Aside from this task, no programming language in the world has any other function. Okay, so move on to our next question. Why are there so many programming languages? There are thousands of programming languages. For the same reason, there are hundreds of types of tools in a hardware store. Different jobs require different tools. Different problems need different tools or application. Not all software does the same thing. Each language is specialized for a specific task. For website, JavaScript is the king of the web because it runs inside your browser. For data science and AI, Python is popular here because it is easy to read and has a great math tools. For video games, C++ is used because it is incredibly fast, which is needed for high quality graphics. For mobile apps, Swift for iPhones, while Kotlin is for Android. Why different programming languages for client and servers? This is our third question. So the main reason is the client and the server have completely different jobs and live in completely different environments. The client or the front end, this is the user's web browser like Chrome, Safari, etc. Browsers are built to understand JavaScript. Since every user has a browser, JavaScript is the universal language of the client side. The server or the backend, this is a powerful computer far away. You own it, so you can install any language you want like PHP, Java, Python, Ruby. You are not limited by what a browser can do. Okay, so move on to our next agenda, understanding programming paradigms. What is a paradigm? Okay, grouping or classifying different programming languages based on their features and style is known as a programming paradigm. There are two types of paradigm, imperative paradigm and declarative paradigm. So imperative paradigm, this is a detailed description of how to do something. Here you tell the computer step by step exactly how to complete a task. For declarative paradigm, this is a description of what you want. Here you do not give the computer step by step instructions. Instead, you simply state what result you want. The computer figures out on its own how to do the job. Okay. there are two types of imperative paradigm. They are um, procedural and object oriented. Like here is a great example of imperative paradigms. Suppose you are telling your friend to make a tea. You say, go to the kitchen, turn on the stove, put the water in the kettle and tea leaves and so on and on. And in coding, running a loop or changing the value of a variable step by step is part of this approach. For declarative, there is an also example. Simply, you can tell a friend, give me a cup of tea. You didn't say how to make the tea, you only stated what you need. Encoded for SQL for databases and HTML, CSS are declarative. For example, CSS if simply in CSS you simply say color blue. How the browser turns the text blue is up to the browser. Then here are types of imperative paradigm. This is a description of procedural and object-oriented. It is a Bangla description. You have to translate it in your language and learn it. Is this declarative paradigms. There are four part declarative paradigm: functional programming, logic programming, mathematical programming, and reactive programming. For now, we will not need logic programming and mathematical programming. We'll be needing functional programming and reactive programming. Here you can see the description of functional programming and reactive programming in Bangla or Bengali. You can translate it in your own language again, or you can Google or like use ChatGPT or Gemini and learn and understand properly what procedural, object-oriented, and functional and reactive programming are. Okay, and uh, which languages are classified in which paradigm. You have to learn properly. Now, based on compiler, there are three types of programming languages. They are compiled, interpreted, and just-in-time. Compiled languages. Compiled means the code I write is converted directly into pure machine code or binary code. Compiled languages are very fast, like C, C++. There are three steps in a compiled language. First, you write the code, then you build it into an .exe or .class file, then finally you run it. The pros of compiled language: it takes time to compile, but the execution time is very low. This makes the program run very fast. Another advantage is that if there are errors in your code, the compiler will catch them during the build process. This is called a compile time error. It has a cons. It takes more time to boot or start, so the actual execution is very quick. So an interpreted language starts running the code immediately. It reads and executes the code only when it is needed. Python is a great example. If you write Python code and click the run button, it doesn't read the whole thing first because it doesn't compile beforehand. It might start running even if there is a mistake or somewhere deep in the code. It reads the code and converts it for the machine only at the moment it is needed. This is why you often encounter runtime errors in these languages. It has a pros they take very little time to start, but the execution itself is slower. There is also disadvantage is that it may compile the same piece of code repeatedly. Therefore, the execution time is much higher. This makes interpreted languages slower than compiled one. Now for just-in-time, There is no hassle of compiling the entire code at the beginning, so the program starts running quickly. The longer the program runs, the most just-in-time programs optimizes the code. As a result, it eventually becomes as fast as a compiled language. Also, it can make real-time decisions at the runtime on how to execute specific parts of the code to achieve the best possible performances. For example, JavaScript was once an interpreted language. Okay, now it is just in time. Then there is the example of Golang and Dart, etc. This was all for today. Thank you so much for being with me. Subscribe to follow my growth.